Hello everyone, my name is Pritam and welcome to another video of the C programming playlist. And in this video we are going to talk about pointer to an array. Okay, so previously I told you guys pointer to an array is very much essential. Actually this concept is very much essential to crack down the data from a matrix or a two-dimensional array. We all have discussed. Okay, if you haven't watched that video, I would say go to that video first, and after that come back to this video, because without that one, or if you have prior knowledge about 2D array, so that is okay. Okay, then let's start. So pointer to an array. What are pointer to an array actually? Okay, pointer to an array. So previously what we have learned is like int asterisk p. So what is that? P is a pointer that is pointing to an integer. What would be the diagram of it? Like for example, this is an integer, for example int a equal to 10. Okay, and for example it would be integer asterisk p. Okay, and it is pointing to a. Okay, so obviously if the address of this one would be 100, it will store the 100. Correct. Now this is like a basic pointer to an integer. Okay, why we are using it, where we are using it? Actually we are using it to extract the data, okay, from the 1D array. For example, this is a one-dimensional array. Okay, and there are a lot of elements are there. Okay, if you have a pointer p which is pointing to the base address, which is in, for example, 100, so incrementing the index, okay, or adding one by one, you can directly move to this one, to this one, to this one, to this one, to this one. Okay, when you are adding p plus 1, the cursor is moving towards this place, then again it will move toward that place. How it is happening? We are using an integer asterisk p. Correct, we are using an integer asterisk p. But when it is about a 2D array, this thing will not work. Why I am telling? Okay, let me explain it. For example, so this is a 4 by 3 matrix. For example, the index starts from 0, 1, 2, 3, and here the index is like 0, 0, 1, 2. Okay, so if these are the indexes, okay, now for example the base address, how it will be implemented? Okay, I am writing the addresses as of now. It will be obviously 100, it will be 104, it will be 108, correct, and it will be 112, it will be 116, it will be 120, it will be 124, it will be 128, it will be 132, it will be 136, it will be 140, it will be 144. Okay, now if you have to jump, okay, for example, now if you have to take this value, okay, what will you do? You will jump here, here, and then here, and then here, 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 here. It will take like how many? 1, 2, 3, 4, 5, 6, 7, 8 jumps. This is not a healthy one, okay, to go towards like that. So that's why, okay, you can use pointer to an array. If you are using a pointer to an integer, what will you do? You will point out here, then here, then here, again this one, this one, this one, and then you will get this one. But if you have pointer to an array, then what will happen? What will happen that like by using pointer to an array, okay, so pointer to integer, if the data type is pointer to integer, okay, it will jump by the size of int, which is 4. Correct. If you have pointer to an array, then use your common sense and tell me what will you if you add that p plus 1, how many bytes it will jump? Obviously it will byte the jump it will jump the byte of the size of the entire array. Okay, now if I have an array pointed to an array of 3 elements, then by that I can directly jump from here to here. Correct, then again here to here I can jump. So by 2 jumps, like by first jump, after the first jump it will come here, after another jump it will come here, and after that I can jump here. So only by 3 jumps I can achieve the address 128, whereas it previously it was taking 1 2 3 4 5 6 7 8 jumps. Okay, so that is how you will reduce the number of jumps and operations, and it will be obviously it will be efficient. That's why actually the scientists or the engineers have come up with this kind of solution like pointer to an array. I will tell you why it is so much useful. You will say that okay bhaiya, it is like kya hi hai, it is normal only, but no. When you'll be talking about multi-dimensional arrays, okay, this kind of approach is going to give you a lot of efficiency in terms of time. Okay, and that's why it is very much essential to learn. Now let me tell you that what is the syntax of declaration. Okay, declaration of pointer to an array. Okay, pointer to an array. So what was that? Integer asterisk p, correct? It is integer asterisk p. Okay, so I told you also, like, it depends on the precedence and associativity thing, right? Here also I told you how will you take it. It depends on the precedence and associativity. As it is a left to right associativity, that's why we took this this one first and this one second. That's why array is a array of ARR is an array of 4 elements. Those elements are array of 3 elements, which elements are integer. Like that, here also we have to use something like that, and we have to write it like, for example, okay, let me write you. If you write integer asterisk p, okay, then obviously it's a pointer to an integer. For example, p of 3. For example, now what will happen? Obviously, whose precedence is coming first? This one. This third bracket is having higher precedence than the asterisk. It's a unary operator, correct? So obviously, p is an array of pointers which are pointing to integer. So this means what? Array of pointers or pointer array, I would say. Okay. This is, we will talk about this section separately for sure, but now this is not the one which we are actually trying to achieve. What it will have, like, it will have array of 3 pointers which are pointing to some different integers, correct? That's it. For example, it is 100, it is 200, it is 300. So it will store all those values 100, 200, okay, and 300. That's it. Okay, so this is not what we are achieving. Okay, this could be 5, 10 or 15, for example. Okay, this would be p. This is not what we are looking at as of now. This is a pointer array. What we are looking at is a pointer to an array, correct? Now let me twist it. Okay, integer asterisk p of, for example, 3. Let me put another bracket here. Now what will happen? The precedence will be coming. This is first and this is second. So obviously p is a pointer pointing to an array of 3 integers. That is how we can achieve it. P is a pointer which is pointing to an array of 3 integers. So obviously it will like p is pointing to an entirely, it is pointing to the array of 3 integers. Obviously it is 100, it will be 100, but there is a difference between this ptr and integer asterisk p. What is the difference? When you will add some 1, it will jump by 4 bytes, whereas it will jump by 12 bytes, because size of the array is 3 into size of int. Okay, that is how it will jump. Got it? So that is all about pointer to an array. Okay, now let me go to the VS Code and check either everything which I am telling is correct or not. Okay, so here you can see, okay, this is the code actually. Okay, so integer asterisk p, it's a pointer to an integer, can point to an integer, whereas it is can point to an array of 5 integers, correct? So what is the difference? Okay, the difference is something like, if we are having an array of 5 integers and if I p equal to arr, which means what? It means like p will be pointing to, okay, let me draw and let me show you guys. Okay, this is, for example, arr of 5. Okay, and there are 2 pointers. First is p, another one is ptr. So the base address is 100, 104, 108, 112, 116, 120. Okay, here it is containing 100, here it is also containing 100, that is fine. Okay, so PTR is what? PTR is integer asterisk PTR of 5, whereas it is only integer asterisk P. Correct? This is the definition. Okay, is pointed to an integer, is pointed to an array. Now, if we like, for example, let me print the actually address which they are containing in the initials, and then after that, let's increase them. Increase the value P plus plus and PTR plus plus, and after that, let's print the value of the addresses. Let's run and see that. Okay, acha, okay, you can see that P equal to A14 and PTR equal to A14, whereas it is coming 18, whereas it is coming as A28. That means obviously some bytes, more bytes, it has been jumped up. Okay, let me do one thing. Let me write all these things in D, and it will help you to understand, as it is in the hexadecimal format. Okay, although it is not advisable, that's why these warnings will be coming up, but yeah, it will be easier for us to understand. It is 44, where it is coming as 48, and it is coming at 64. So you can understand the difference. 20 bytes it has been jumped, because 5 into 4 equal to 20. That's it. Okay, so that is how actually pointer to an array works. It is actually nothing but it will jump the entire array. Got it? So what will happen in the MacBook, in the iPad, if you see, so here it will jump from here to here, whereas it will jump from here to here. That is the difference. So once I can jump the entire array, so that is how we can achieve this one. From this array I can directly jump to this array by jumping the entire one. Then again, by jumping the entire one, I can come to this place. Okay, I can come to this place, and then by using pointer to an integer, we will talk about it, don't worry. Using how will you use it, we will talk about it. We can directly jump from here to here and get the value at this address, and that is why the pointer to an array is very crucial while working with the two-dimensional arrays. Okay, so now let's go to another code and try to understand what is the size. Okay, what's happening there. Okay, program, like it's a program to difference a pointer to an array. Okay, here what we are having, integer ARR equal to this, integer P equal to ARR, and this is the pointer to an array. We are going to print the addresses again. Okay, and then size also. Okay, so let's run the code. Okay, so here you can see, okay, asterisk P equal to this, PTR equal to this. Okay, let me do one thing. Okay, let me remove it and write it as %d. Okay, it will help us to understand. Okay, yeah, so let me run again, and you can see here what is happening. P and PTR both are same. Okay, P and PTR both are same, whereas okay, asterisk P is 3 and asterisk PTR equal to this one. Okay, and then size of P is 8, whereas size of asterisk P is also 4. Okay, whereas size of PTR is also 8. Size of P and size of PTR both are same, because these are containing all the addresses, and size of PTR equal to 20. Now why it is happening? Okay, you try to understand that. Okay, so pointer to an array. Okay, when we are printing this addresses, these are coming same. Asterisk P and asterisk PTR, obviously these are different. Correct? Why it is different? Because it is not pointing to the first element of the array. Try to understand it. It is not pointing to the first element of the array. Okay, pointer to an array points to an array. So on dereferencing if we should get the array and the name of the array which actually denotes the base address. Okay, so whenever a pointer to an array is dereferenced, we get the base address of the array in which it is actually pointing to. It is not giving us the value. Try to understand it. This is very much important. Okay, when we are actually dereferencing it, you could see the entire address is coming here. It will not be same. Okay, because okay, let me drag it out again. Okay, you could imagine like this. Okay, let me draw these things. Okay, so there would be another one here, you can see. Okay, this is also 100. Okay, I'm just trying to make a difference, try to make you understand that, so that it will be easier for you, because this concept is going to be implemented in the next code also, which I will be showing you. So P is pointing here, whereas PTR is pointing here. It will jump the entire block, and it will jump only one integer by integers. Okay, that's why when you are dereferencing it, okay, inside this one, when you are going, it is coming to this address only. Okay, when you are like moving inside this one, obviously what will happen like this, but when it is going inside, it will get the value, and that's why asterisk P will give you the value 5, whereas asterisk PTR, okay, PTR and asterisk PTR both are same here, because it's a pointer to an array. Okay, so PTR will give you the address, asterisk PTR also will give you the address, because it is containing the address of the entire array. You are getting my point, correct? Size of P is 8, size of asterisk P is 4, size of PTR is 8, because both are pointers. It will contain the address only, which is an integer. That's why size of all the same type pointers are same only. Okay, that's the thing. If you are like size of float also, like size of pointer which is pointing to a float, size of pointer which is pointing to an integer, size of pointer which is pointing to a character, all are same. I already showed you in the previous videos of pointers as well, right? So these are same, but size of asterisk 4 and size of asterisk PTR, okay, these are different, because it is 20 and whereas it is 4. Okay, now let me just write it out. Okay, printf, okay, %d comma double asterisk PTR, okay, for example, and let me run it. Okay, you could see, okay, one second, you could see here that it is printing 3, which is the first element. So that is what actually it means. Now when it is pointing to an array itself a pointer also, so it's a pointer to pointer also, that kind of concept is coming. That's why I tried to use it double asterisk to insert another one. Like what is happening, okay, in the notebook, if you can I can the diagram, what we can see, by first one we are getting 100, we are inserting, and we are getting another 100. To insert, like to get into another one, we need another asterisk, right? This asterisk is needed to get into this one. Okay, another asterisk needed to get into this one. That's why I use double asterisk in the code, and you can see that when the double asterisk is there, it is printing the 3. Could see. Okay, so this is all about the pointer to an array. It's a very important concept to understand, because in C programming, pointer is the ultimate power actually, which actually given by the C developers to the developers, so that you guys can like understand that what exactly happening inside the memory. It's very memory, like it's very near to the memory actually. In Python also, what you are writing, all these things like actually will be in the background, it will be running by C or C++, but or these days Rust also. But in case of C, there is nothing. C is directly interacting with the memory using pointer concept. So that's why pointer is used to call as the like a powerhouse of C programming. Okay, you should know how pointers work. Okay, now let's talk about pointer to an two-dimensional array. Okay, let me draw 4x3 matrix. I think one 4x3 matrix we will draw. I hope these things are getting more clearer. Okay, so this is row 0, row 1, row 2, column 0, column 1, column 2, column 3. Okay, so let me put some values. So 1 0, 1 1, 1 2, 1 3, 2 0, 2 1, 2 2, 2 3, 3 0, 3 1, 3 2, 3 3. Okay, ARR of 3 by 4, because rows are 3 and column are 4 columns. Okay, so what will happen, equal to what? Here it would be 1 0 1 1 1 2 1 3 comma 2 0 2 1 2 2 2 3 and then 3 0 3 1 3 2 3 3 and then semicolon. Correct. Now if you want to extract the data, okay, from like using the array like pointer or direct point like dereferencing operators, so how will you do that? Okay, so obviously this is ARR. ARR means what? The base address of the array, entire array. Okay, ARR plus 1 obviously and ARR plus 2. Okay, and what will happen there? Okay, ARR means what? ARR means points to the 0th element of the array, okay, or points to the 0th element of the 1D array. Okay, okay, let me drag it down more and okay, so obviously what will happen? It will be ARR of 0. Okay, it will be ARR of 1, it will be ARR of 2. That's why I have written ARR, ARR plus 1, ARR plus 2. Okay, because plus and this one are already same. Okay, and by the way, another thing I'm just telling, okay, this ARR of 0 and 0 of ARR both are same. You know why? Because ARR of 0 means what? ARR plus 0. So 0 of ARR will be what? 0 plus ARR. So both should come, both will come the same value, which is the address. Okay, so that is how pointer actually will work, and computer also by C language, computer also will go to that address and then it will pick up the value. Okay, so all are same. If you write 0 of ARR also, it is going to be the same result. You can try it out in your VS Code. Okay, so now what exactly ARR is? Okay, ARR is nothing but, okay, ARR is nothing but points to the 0th element of ARR. Okay, you can take a note of all these things. Points to 0th element of ARR. What exactly it means? It means points to the 0th 1D array. I would say 0th 1D array. Obviously what will be the value? The value will be 100, for example. Correct. Now what is ARR plus 1? It is pointing to the first element of the array. That means points to the first 1D array. Correct. That means what? Points to the first 1D array means this one. That means 116. Correct. Now ARR plus 2 means what? Points to the second element of the array and points to the second 1D array. Correct. That means what? That means this one, which is 132. Okay, that means 132. This will be the address. Correct. So this is how the thing. So in general what we can write is ARR plus I. This means what? It's points to the ith 1D array. Got it? 1D array, not the element, by the way. It is pointing to the ith 1D array. Okay, pointing to the entire array, which means pointer to an array, not pointer to an integer, by the way. Okay, so okay, correct. So this is one conclusion which we got. The another one is, okay, now if you put asterisk, okay, if you put asterisk ARR plus I, what will happen? It will points to the, obviously what it will hold, we have shown already in that code also there, like what it will hold. Obviously it will hold the address only. Okay, it will hold the address. If you want go inside, it will hold the address only. So what it will hold, it will hold like actually points to the first element of the zeroth actually 1D array, correct? Sorry, it will not be first, it will be zeroth element of the sorry, one second, it will be like a zeroth element of the like ith 1D array, correct? Zeroth element of the ith 1D array, correct? So this is also another conclusion. Okay, if you put asterisk here, what will happen? See, if the ARR plus I is pointing to the ith 1D array, putting asterisk means what? It will insert that one and it will give the first element address, the first element. If you put another asterisk here, okay, it will give the value of the array, value of the element of the that 1D ith 1D array. Okay, so that is the thing. Okay, so now what exactly asterisk means? Points to the zeroth element of the ith 1D array. Okay, points to the zeroth element of the ith 1D array, correct? Now if you write, okay, if you write some other things, like for example, okay, so if you write now for example, let's put another asterisk. Okay, so if you write like for example asterisk ARR plus I, okay, if you put like that, then what will happen? It will jump, okay, sorry, it will be J, okay, it will be J, and this value, what it will do? So obviously, as why I am saying it is a zeroth element, because it is a plus 0 is there. If it is plus J, then it will be pointing to the, actually points to the jth element of the ith 1D array. Got it? It will point to the jth element of the ith 1D array, correct? Now if you want to get the element, then what you have to do? You have to write an asterisk here, then asterisk ARR plus I plus J. It means element, like it, what it will do, it will be representing, okay, so let me write it properly, represents the value of jth index of the ith 1D array, which means actually nothing but ARR of I of J. That's it. It means this one. Okay, nothing more. So this is the thing which is very much crucial. If you didn't get it, I would say try to understand it properly. Again, you watch this part and then you will understand. Okay, let me draw a diagram. Actually, I would say it will be very much useful for you if I draw this diagram, I think. Okay, so what exactly ARR means? ARR is pointing to the array. Okay, again it is pointing to, okay, not like this, do one thing. Okay, let me do some this kind of things. I think it will help you. These are the arrays, correct? I'm drawing this diagram just to make you guys understand. Okay, so please try to understand what we are trying to mean. Okay, Yeah. So what exactly ARR means? ARR means pointing to this one. Okay. Whereas ARR plus 1 means pointing to this array. ARR plus 2 means what? It is pointing to this one. Whereas asterisk ARR, it is pointing to this element, first element. Okay. So asterisk ARR plus 2 means what? This is pointing to this element. Okay. Now if I want to write, like for example here, asterisk ARR plus 2 and then plus 3, it is pointing to this element. But if I talk about asterisk ARR plus 2 plus 3, then it is pointing to this element. Try to understand where I am pointing. Okay, it is going inside the cell, whereas it is staying this without asterisk, it is staying outside of the cell, and this is staying inside one, and this is pointing to the entire. That's why I have like this orange color outline I have drawn to make you guys understand that this is a separate array, for example, and it is staying outside of the array. And what is this? This is nothing but pointer to array. Okay, and that is why, okay, to declare it, okay, to use the subscripting pointer, if you ask me, okay, for example, if there is any pointer which is called ptr, asterisk ptr, okay, or only ptr, and it is containing the address 100, and if I have to access it, how will I code it? Okay, that is the most important thing. See, this is the one. Okay, if you see here, okay, what are all these things? Okay, so this is ARR of 3 of 4. Okay, asterisk PTR of 4. Now why we have taken 4? Okay, you need to understand that. So how many columns are there? Okay, how many bytes I want to jump? Just look at here, how many bytes I have to jump? 4 elements I have to jump, right? So the pointer, okay, the pointer will have to point to an array of 4 elements, and that's why in the code here, okay, I have explained this like I have declared this as asterisk PTR of 4. Okay, and then PTR equal to ARR, and now if you see PTR1, PTR2, PTR plus 2, then asterisk values and all these things, let's run the code and you will get it. Okay, so yeah, so here you can see F8, okay, then 0. Okay, let me do one thing. All this asterisk P, let's remove by % of D, and then let's run. Some errors like warnings will be coming up. It's okay. So if you see 48, 64 and then 80, 48 plus 4 into 4, 16, so it will come like that, 64, and then again plus 16, it will come 80. Whereas if you see asterisk also, the values are coming same as I told already in the earlier code. This one also, okay, it will be coming same. Okay, now the next one, okay, 10, 12, okay, 10, then 22, okay, 22, okay, PTR plus 1 plus 2 na. So plus 1 means what? This one. Plus 2 means what? This one, this element, okay, and PTR plus 2 plus 3, that means 33 will be printed out. So here 33. Again, if you see the check the like values, either these two are coming same or not. So by the like subscripting operator also you can use, using dereference operator also you can use, like both of them I have shown here in this code. Okay, and that is how actually you will have to actually extract it. Okay, and that's all about. Okay, now let me talk about another topic here. Okay, pointer to an 3-dimensional array. There what will happen? Now what exactly 3-dimensional array is? Okay, in a 3-dimensional array, so 2D array, what you have understood? Okay, what you have understood? 2D array, this. Okay, so this is the first row, this is the second row, and this is the third row, correct? So obviously you will put the first row first, and then you will put the second row, and then you will put the third row in the linear order. Now what exactly 3D array is? 3D array is something like, for example, like a cube. Okay, So this is like a cube. Okay, you join all these things, and let me write like this. Okay, and for example, so here what you can see that, like for example, if I ask, like, this is the first 2D array, okay, this is the second 2D array, obviously, and this is the third 2D array, correct? This is how 2D arrays we are actually stacking into. Okay, so now what will happen, like for example in the 3D array, what will happen? Okay, so for example it's a length of 3, so this is one 2D array will be there. Okay, if you like watch it from the top, this is another 2D array, and this is another 2D array. Okay, so that is how actually it is. So one 2D array means what? Obviously another array of 1D arrays, correct? So let me give you some example. Okay, how we can declare it. For example, int arr of 2, then 3, and then 2, for example. Okay, so what will happen, that arr is nothing but an array of two arrays, which are actually array of two 2D arrays, and which are like array of 3 elements, which elements are array of 2 elements, 2 integers. Okay, so what will happen? Okay, so here like I will put some bracket. Okay, so obviously it will be 3 by 2 arrays, correct? 3 rows 2 columns, correct? So first one will be like for example 5, 10. Another one is will be like 6, for example 11. Another will be like 7, 12. So this is one 2D array, comma. Okay, now the another one will be what? Okay, sorry, one second. It will be not like this here. Okay, now here it will be comma, the another 1D array, okay, a 2D array. Okay, for example 20, 30, and then for example 21, 31. Hold on. Let's write like this. I think it will be easier for you to understand. 5, 10, then 6, 11, then 7, 12. So this is one 2D array, correct? Comma. Okay, let me colorize all these things. I think that will be proper for you to understand. Okay, it will be one thing. Okay, now okay, let me drag this also. Some colorizing, if we use, it will be easier for you to understand. Now, so this is another 2D array. For example, what will happen, like here for example 20, 30, then again 21, 31, then it will be 22, 32, for example. So here it will be another one. Okay, and at the end this one. So what is happening? So this is one 2D array, first or 0 2D array, I would say 0th 2D array, and this is the first 2D array. So one 3D array is combination of some 2D arrays. If you put 2D arrays in 1 by 1 location like this or like this, then obviously it will look like this. Obviously the physically we know how 3D things look like. If I talk about 4D, I would say like another box will be coming here, another box will be coming here. So that is a separate thing. 9-dimensional multi-dimensional array is also there, and to compute with, like in modern days, like we are using Python also, like numpys and all, pandas and all that there, right? Just let's not get into those things, but yeah, using internally this kind of, actually what I am teaching you guys, this kind of internal implementation is getting used. actually to extract the multidimensional array or multidimensional data, okay, using Python actually. Okay, so that's why I think like that's why I always say like C is the most important language you should understand from the scratch actually. Okay, so it will be easier for you also to understand how memory actually works. Okay, so this is all about that. So 2D array, 2D array, one 2D array, this is another 2D array. Now ARR is nothing but an array of 2D arrays, which 2D arrays are array of 1D array of 3, and those 1D arrays are element of 2 integers. See, 2D arrays, 2D arrays. What is the size of the 2D array? Like here 3 by 2, 3 by 2 actually, correct. Now this 1D arrays are of 2, so this is about this is about this, and the entire thing is about this. Okay, that's how the 3D array is. Now using pointer, how will you extract the data? Okay, so obviously ARR means what? Obviously it will point to the first one. Then asterisk ARR plus I means what? It will point to the first ith 1D array. Okay, ith 2D array, 2D array. Now if you put ARR of plus I plus j, okay, so what will happen? It will like jth 1D array, jth 1D array of ith 2D array. If you put another asterisk ARR plus I plus j and then again asterisk, okay, it will put what? Okay, it will put nothing but the address of the like jth 1D array of the ith 2D array. Then again if you put like asterisk ARR plus I, okay, plus j plus k, it will point to the kth element of jth 1D array of ith 2D array. Now again if you put asterisk here, okay, asterisk of ARR plus I plus j plus k, that means it represents actually nothing but ARR of I of j of k. That's it. This is all about 3-dimensional array using pointers. Okay, so that's all about today. I would say watch this video multiple times so that you could get a good understanding or get a good understanding of how actually we are using pointers actually. Okay, so try to understand these things, and I would say take proper notes. Okay, and if you want like this PDF, you could like join the WhatsApp channel. Okay, and also let me know in the comment section, then I will share in the WhatsApp channel and you guys join there and you can easily get those things. Okay, so yeah, that's it for today. In the next video we will talk about call by reference. Okay, that is a very important thing for pointers, and how call by reference is different from call by value. We will talk about those basic stuffs as well. Okay, thank you so much for the patience and watching this video till the end, guys. See you in the next video.